All right, ladies and gentlemen, let's get to today's math class. I've been having a little bit of connection issues, so hopefully this video will be able to be recorded and you guys will be able to understand it properly. So today we started with a new section. We talked about direct variation, and what I'm going to do in this video is very quickly explain what direct variation is, and we'll go over some things. So direct variation, pretty much in simplified terms, is when two variables are directly related to each other. For example, kind of like cause and effect. I mean, if you uh, eat too much, you'll get a stomach ache. Effect, stomach ache. Cause, I ate too much. So direct variations are where two variables are related directly. Now there are some differences in how some people express direct variation. For example, in the textbook that we have, the equation for direct variation is y equals a times x, where a is a constant and x, of course, refers to, and there's no slope, right? In some other textbooks, you'll see it as y equals k times x. And really, y equals k times x, it doesn't, or y equals ax, it really doesn't make a difference. They both mean exactly the same thing. The a and the k represent a constant. So I'm just writing that there to compare, but don't worry about it. The one that we're really going to use is this one right here, y equals a times x. And in this, where a, as I mentioned, is the constant. Okay, so constant, let me just see if I can write that down and make it look nice. Constant, A-N-T. Okay. And, well, there is no B, or B equals 0, right? And usually when we have a direct variation equation, the graph always goes through the origin. Let me use a different color. The graph always passes through the origin. So it'll usually look something like this. Now, mind you, if A is positive, the graph will look like this. Okay? If A is positive, the graph will look like this. And let me write that, A is greater than 0 or positive, this is what the graph would look like. If A were less than 0, then the graph would probably look something like this. See, just to kind of compare, the blue graph kind of looks like you're going up an escalator, and then this red graph just kind of looks like you're going down the escalator, right? So A, okay, give me a second, guys. This is when A is less than 0. So here's when A is less than 0. And it's important to understand that, especially because of the example that I'm going to discuss with you guys real quick, okay? So just to kind of recap, direct variation, y equals a times x, where a is a constant, and b is 0. Let me fix that because that does not look like a 0. I just realized that. And b is 0. And basically, if the equation, if a is positive or greater than 0, like you can see in the blue equation, you'll see that the graph is going to look like this, like it's going up an escalator or up a staircase. If a is less than 0, then that means that the equation looks like the red line, where it looks like you're kind of going down the stairs. So let's look at example number 1, and I'm going to do at least 2 real quick examples to compare. Example number 1 of your textbook, let me erase this. Gives us an ordered pair, and sorry about that. Let's see if I can draw that line straighter. trying to be kind of like a perfectionist, and I'm still getting the hang of this, but let's see if this will be straight enough. So this is the equation, right? And the ordered pair that we have in that example is -4 and 8. So let's see if I can draw this a little better and be able to illustrate it to you guys. So let's do that real quick. So -4 and 8. So if 8 is my y, let me just draw the little tick marks. 2, 3, 4. I know this sounds kind of weird, me counting, but I'm just making sure that I draw everything as accurate as possible. 6, 7, and 8. So, okay, so basically this is -1, -2, -3, and -4. So -4 and 8 would be about here. Now I want to graph that. So in order to graph that, let me just write that. This is -4 and 8. Okay, so what I need to find in order to graph this is my constant of variation. So I have my equation, y equals ax, and I need to find a. And what a is going to do is it's going to indicate two things. One, if the graph is going to be positive or negative or anything like that, and two, more or less where at what points the graph would intersect. Now I know for a fact that in a y equals ax equation or a direct variation, there is no y-intercept, which means that I know for a fact that this graph has to go through the origin. I know for a fact that this graph has to cross the origin at some point, if in fact this is a direct variation, because maybe it might not be a direct variation. So let me go ahead and just find the value of a. And to find the value of a, I use the ordered pairs here. So x is -4 and y is 8. So then I'm just going to say 8 is y. And again, I got that, guys, and let me write it here from the ordered pair that is in example number 1 on page 107, where you have the ordered pair -4 and 8, and I want to write an equation or a direct variation equation, and I want to graph it. So I know that x is, or 8 is y, a is what I'm looking for, and x is -4. So in order for me to find the value of a, I solve this like I would any normal equation, and I divide by -4. And 8 divided by -4 is actually going to be -2. So if a equals -2, that means that my direct variation equation is going to be y equals -2x. Now to graph the other points that are going to be in this line, well, I know how to do that already, because technically if the constant is 2, sorry, give me 1 second. Here you go. If the constant is 2, that means that from this point right here, I can count 1 space down. So 7, 6, and 1 space to the right. And I know for a fact that this is more or less where my other point is going to be. And I also know, actually, right here. So let me delete the one on the bottom. Just, you're not always going to get it perfect, just so you guys know. You're always going to get kind of like a percentage, more or less a night of where it's going to lie. So don't feel discouraged um, if you guys all of a sudden it doesn't come out like the way you wanted to, or you're having a little bit of difficulty with it. Don't worry about that. So it passes through the origin, and I know for a fact, and then all I do is I kind of connect the dots as best as I can. And there is my graph, more or less. Let me just kind of draw it a little better so you guys can observe it better. So technically this is where my negative 4 and 8 point is. And let me color this one in red so you guys have an idea. And this is where my other ordered pair is, more or less. And then I just graph it, right? It looks like I have colors of the rainbow. One very important thing that you guys have to understand about drawing a direct variation equation is that the slope, or not the slope, I'm sorry, the y-intercept is 0. So it has to pass through the origin. It has to go through the origin. If it doesn't go through the origin, then it's probably not a direct variation graph, okay? We'll do one more example real quick, and then that'll be it. This one is actually in your book. So let's do the same thing, but with a different ordered pair. So I'm going to go ahead and erase all this. And I'll go ahead and erase this. And I'll go ahead and erase this. So that I didn't need to erase. Give me a second. I'll fix that. So this one is actually in your book on page 107. Let me fix this. You have y equals ax, and the ordered pair that you have in this case is 3 and negative 9. So positive 3 and negative 9. Let me delete that. Sorry. Positive 3 and negative 9. So if you have 3 and negative 9, the first thing you want to do is let's just find the a, and then we can focus about on the graph. So 9 is y, so that would be negative 9. We could graph that ordered pair and then find the constant. It really doesn't make a difference. So for this one, I'm just going to find the constant first, and then I'll graph. A is what I'm looking for, and x is 3. So if I want to find the value of a, all I do is divide by 3 on both sides. And that would be that negative 3 equals a. So that means that my equation is now going to be y equals negative 3x. So let's go ahead now and graph this real quick. I know that my graph has to go through the origin if it's direct variation because of the fact that it has, or that the y-intercept is 0. But let's graph the points. Let's graph the points. The first point that we have is 3 and negative 9. So positive 3, 1. Oh, sorry about that. So that would be 1, 2, and 3. And then we're going to do the same thing down here, right? So And okay, so 3 and negative 9 would be 3 and negative 9 down here. And that would be it. Now, it says negative 3, so that means we actually move from this ordered pair 3 spaces down and 1 space to the right. So 3 spaces down. Give me 1 second. 3 spaces down. So so 3 spaces down. 1, 2, 3, and 1 space to the right, more or less here. And since this is a direct variation equation, that means it has to pass through the origin. So let me go ahead and change the color one more time. So here's my origin, 0, 0, because the slope is, the y-intercept, excuse me, is 0. So I kind of connect the points as best as I can. And this would be my graph. And notice that because a is negative, once again the graph appears to be going down a staircase, and this would be the rest of the graph. And that's pretty much how we graph direct variation equation, ladies and gentlemen. Hopefully this video will clarify any doubts that you have. The exercises have been uploaded on your platform, and we will see each other in our next class. So stay safe and bye-bye.